So for instance here, my domain is just all reals. It's negative infinity to infinity. That's going to be the same when you're subtracting and when you're multiplying. The only time we're going to have an issue is when we get into things that have fractional issues, because I can't have the denominator equal 0. Well, here I can plug in any number for x. I'm going to get an answer out. It's going to work. If I subtract the same two values, f of x and g of x, the only difference is going to be now I have that minus that I have to think about, almost as though I'm distributing it. So 2x minus x would be x, and then this minus is going to switch the sign here and make it a -1 or a -1. But again, there isn't a number that I couldn't plug in for x that I wouldn't get some answer out. Fraction, decimal, positive, negative, doesn't matter. So you're like, okay, this seemed kind of strange so far. Multiply, okay, we've done this. Multiply, I just distribute through and multiply. Add my exponents. 2x times 1 is 2x. And again, there's not a value I can plug in for x that will not give me some sort of a solution out. So domain's all reals, negative infinity to infinity. Now comes the one that has the catch. F of x divided by g of x. Now there's two things I want you to think about here. Number one, I put parentheses around that x plus 1 for a reason. Usually when people don't, the first thing they want to do is cancel the x's out. And I'm like, oh no, you can't do that. That plus in there, when you can see that bond with the plus, you can't break that unless there's something in all three that I can break that with. Since there's no x here, I cannot cancel those. This is as far as this is going to reduce. However, I can't have a 0 in the denominator. My g of x can't be 0. So I'm going to take whatever's in the denominator and set it to not equal 0. So if I subtract the 1 over, I find out that x can't be -1. So my domain, and again, it depends on how picky people are with how you're going to describe domain. Some people would say it's, bless you, it's absolutely fine to just say x is not equal to -1. That would tell me enough. But if we wanted it in interval notation, this is going to seem kind of strange, but it works. If you go from negative infinity to the value and use a parenthesis, so like if I were using a number line, I'd be saying, okay, I'm coming from negative infinity, I get to -1. I'm stopping there. I'm not counting it though. But then I start again on the other side of it. That's basically me saying I want every single value except this. But I have to use the parentheses in order for that to work. So if I used a bracket, it'd be everything. So this is the preferred way that we like to be able to see it when we're doing it, because interval notation shows up more often than anything else does. So that's basically it with these. We're going to go through, we're going to try and do whatever operation we're being asked to do and kind of simplify it from there. So for instance, let me bump this up a bit. F of x plus g of x. You're like, okay, f of x plus g of x, and it's a negative, so I just put the negative instead of putting plus a negative. Can I put these together? Call it like -4x to the 5th? No. When I'm adding and subtracting, if you don't have the same exponent, you're done. But it's going to be the detail stuff that may get some of you in this section. So like here, if I'm subtracting g of x, remember you're minusing a negative, and when you minus a negative it becomes plus. Still can't put them together though. You're like, okay, well what's really the big deal here? All you're doing is flipping the order around. Sometimes that won't change the value of something much. Like here, if I have -6x squared plus 2x to the 3rd, if I literally had a value to plug in for x, I wouldn't have any difference with these. However, subtraction doesn't work that same way. Minus, if I were to plug in a value here for this versus this, I get a completely different answer. So you do have to watch out to see what order your functions are being given to you in, because if you don't careful with that, it can kind of screw you over actually. So let's see here. What else we got for some weird ones? 2x plus x plus 3. Again, if there's like terms to combine, I need to do that. Don't just kind of leave them hanging if you can go further. F of x minus g of x, okay. Now when you do minus, again, use the parentheses. Because if you don't, I guarantee you're going to forget that that negative works all the way through that quantity. So negative 2x minus x, okay, that's negative 3x. But a lot of people forget and they'll write plus 3. But that minus also goes to the plus 3 and changes its sign. So this is more the detail unit than anything else is. Okay. G of x plus f of x, again, we're changing the order around. Notice, though, my answer itself isn't changing. Again, it's just getting us into the commutative property, which basically says if I take two numbers, I can add them 2 plus 4 or 4 plus 2. I get the same thing. That's showing the same here. And then again, I'm just going to be careful. Minus a negative 2x will become plus. And again, I get something different than I did up in letter B. So again, as long as you're cautious, these really aren't anything that's going to be too terribly difficult. The only thing that seems to give people some trouble is typically when we get to multiplication or division. Because they get to here and they go, okay, so 3x times x to the 1/4. Ooh. Now, when we're multiplying, what do we do to the exponents typically? Add them. So I'm looking at this and I'm like, okay, so that's like 3x to the first. Now typically I'm not going to write something like 3x to the 1 1/4. We just don't do stuff like that. So just a reminder, find yourself a common denominator, please. Like 1 is just 4 over 4. Because once you get here, even though you have that coefficient of 3 in front of your first term, you still have the same base. So I can still add those together. Looks weird, but that's what we're going to be dealing with. And again, since we don't have numbers in there, it's not something I necessarily just be able to go to the calculator to try and fix for me. However, the division, again, is where life gets complicated. So here, there's a couple of things that I could do. What do we normally do with exponents when we're dividing? Subtract. We do the bigger minus the smaller. So here, I'm like, okay, so 1 minus 1/4 is 3/4. The larger exponent is in the numerator. So I just get my 3/4 up there and I'm good. So again, not something that's going to be too hard to deal with. Now, my domain, though, that gets a little bit more interesting because I'm like, well, let's see. Could something to the 3/4. Now let's think about this for a minute. X to the 3/4. How's that look like back in its radical form here? Exponent over index. I can't, so the 4th root is like a square root. What can you not take the square root of and get a real number? Yes, Anything that would be negative, yes. Okay? So I can't get values that are going to be negative. Because if I have anything under here that's negative, and I try to take a fourth root, for instance, if I tried to take, I don't know, oops, it'd help if I put parentheses around it, negative 8 to the 3/4 power. Well, what if I change it to negative 6? Okay. What if I change it to positive 6? Okay. So what am I generally finding out right now? What types of numbers won't work? Negatives. So my x value, and I'm just trying to think my way through it first, has to be greater than or equal to 0. So if that's true, how would I write that in interval notation? 0 to infinity using the bracket. And we're set. So there is some thinking, especially when you get to those problems where you're trying to divide through. Just making sure that you're covering your bases. Now, will they all end up that nasty? No. Okay, f of x times g of x here. Just make sure I distribute. Now, let's see here. Good old division. F of x divided by g of x. What value would cause me a problem this time? Negative 3. Because if x plus 3 can't equal 0 and I subtract 3, I find out that x can't be negative 3. So like we did up above when we were doing our first examples, my domain, I want to cover everything but negative 3, because that's the one value that doesn't work. Everything else is good. Any issues on the first page? Biggest thing to remember, just make sure if there's a fraction, you don't have 0 in it. All right. Not terrible. All right, let's flip over here. Make life a little more interesting when we get to the back. All right, composition of functions. In other words, we're going to plug one function into another one. So there's two ways we can represent these. Sometimes you can say, like if you're going to do f of g, it looks like the word fog is there. Put this little open dot in there. Or sometimes you may see it like f and then g of x in the parentheses or braces right next to it. So, and like it says here, f of g means the same of f of g of x, which means put g of x into f. You're like, what? Okay, so in other words, when it says f of g, what I'm going to do, f of g, plug g of x, and I'm just going to rewrite it this way for a second. Because if I gave you a value, like 3, you'd plug 3 in where x goes. Well, now I want you to plug g of x in there. So here's what that means. I want f of 7x, because that's what g of x is. So you're like, oh, so all I'm supposed to do is take 7x and plug it in where x goes here. Exactly. So I'm going to have 2 times 7x minus 5. And of course I have to simplify. And that would be my f of g of x, or my f of g. But they always will go in the order that you see them. So if it says g of f, that means I'm going to take my g function and I'm going to plug the f of x value into it. So whatever comes first, that's the one we're plugging into. So g of x is 7x, 7 times whatever's in the parentheses. and then I just multiply that out and get an answer. And we got to just keep getting the reminder in. When we get into anything that's fractional, remember, can't have a denominator of 0. That's going to restrict my domain a little bit. So just to get a little more practice, and again, we'll keep putting both ways they can be written here for a bit, but it's always the first one's what I'm plugging into, the second one is what I'm plugging into it. So here I'm going to have f of g of x, which is just plugging this in where the x goes in for f. And get to my solution. And if I flip them, now g is what I'm plugging into, and f is what I'm plugging into it. So let's see here. Two times 3x is 6x minus 1. Now, you also can plug a function into itself. Seems kind of strange, but so f of x, I'm going to plug 3x into 3x. So again, I'm just replacing the x with what f is and getting to a solution. Weird, weird, weird. G of x, same thing. G, what's g of x to plug in? 2x minus 1. So I take my g of x, and when I get to x, I plug in what's in the parentheses. And then simplify what's left with it. So then all we're doing down below, I'm trying to think of some that might cause us a dilemma, because otherwise I would just as soon give you time to be working on stuff rather than playing with a lot of these. Okay, let's move down here. Let's move down to 12. What happens when we start firing numbers in here? There's two ways you can tackle these. This is just multiplying with that little dot in the middle. I could either multiply these together and then plug a 5 in, but I have an easier way. Or I could do f of 5 times g of 5. In other words, substitute 5 in for x in each of them and then multiply them together. So like f of 5 would be 3 times 5, which is 15, plus 2, which is 17. And here, 5 times 5 is 25, minus 4 is 21. And multiplying together. Both ways will get you to the same answer. But again, as you do any of these, you just have to be watching for certain things. So like, let's say, for instance, we go past 13 for just a second here, come down to 14. Ooh, absolute value? Sure. F of 4 times g of 4. So here, let's see. If I plug in 4, 2 times 4 is 8, minus 1 is 7, and it's absolute value, so that's not going to change anything. 5 times 4 is 20, minus 14 is 16, and multiply them together. F of g of x. In other words, take f, plug in g of x. You're like, even into an absolute value. Even into an absolute value. Distribute on through. So 5 times 2 would be 10x. 2 times negative 4 is negative 8. Minus 1 is negative 9. And now I'm going to do the unthinkable. You're like, wait a minute, why are you stopping? Because there's nothing else for me to do. Well, what about that minus that's in there? It's not a value, though, that I'm taking out yet. I can plug a number in, and if the number was negative, I'd still come out positive. But as far as rewriting it, I'm not always going to get to a value on that. I might just get to another expression. But I'm still just doing the plug-in. And then my last one, and then I have a surprise for you. Like, oh, surprises. So they give us this function to model manufacturing cost and to manufacture the service cost. Write a function for the total manufacturing and service cost. Okay. So if I'm trying to find the total, to me it makes sense to take the manufacturing cost plus the service cost, and I'm just adding. Don't multiply, don't try to plug one thing into the other. We're just trying to find the total cost by adding these up. So 1150. Oh, let's see, how good am I today? Yes. And that would be my C of X. That would be my total cost, because I just added the manufacturing and the service cost together. Don't let something with a story problem think this is hard, I'm just going to skip it. Too many of you are doing that, and I'm whacking you on homework checks because, because of it. And most of the time they are. They're set up pretty straightforward where it's something you can figure out. It's just something you've got to work through a little bit. Okay, so here comes the bonus part of this. Normally I don't do this, but I just feel like doing this week. That back sheet, okay? If you choose to do the more practice for 7-1, it is extra credit on the next homework check. If you choose not to, So that's a plus tour, but of course, the book part itself is part of the next homework check. That'll be assignment number 3. So again, book work, have to do it. Practice that the sheet here that it's on, optional. Issues. All right.